Welcome to the building envelope improvement session of our video series. My name is Darryl Paul. Today we're going to be talking about how we can improve on the building envelope. And when we think of the building envelope, one of the important things is to understand what we're really talking about when it comes to building envelope. For instance, when we talk building envelope, there's a whole series of components within that assembly. So for instance, the separation of the indoor conditioned space and the exterior unconditioned space is really a good definition. So that entails everything from the insulation to the vapor barrier inside, the water barrier, the cladding on the outside. That is a building envelope. And that affects everything from the roof through the walls into the foundation. And so for us to be able to get a good constructed building, an affordable building, a building with good energy efficiency, a building that's comfortable, we want to be able to look at all of these components and help you to understand what's the best way to build it. In our earlier sessions, we talked about how we could improve in energy efficiency. We talked about what the new code is going to talk about. But then we also talked about prescriptive versus performance. Now, what's the best way to improve on that envelope? We could put exterior insulation on, we could put insulation between the studs, but understanding what the unintended consequences are when it comes to this path or this path or this path will be very important. So we want to tie in what the code changes are, we want to tie in energy efficiency, but we want to understand in this video what the building envelope is and how we can improve on it. So in this video, we're going to cover some key items within the new building code. So for instance, we're going to talk about the energy code. We can't help but talk about that. That's one of the main discussion points. But when we think of insulation in the energy code, is it better to put the insulation on the outside of the studs, or is it better to put them between the studs? And then we can get into things like multifamily. What's the difference between air tightness in multifamily and single family? How do the party walls affect it? We'll touch a little bit on the fire code, and in particular, that's where it comes in with the party walls and how we can improve on air tightness in party walls. But we'll also talk about window installations and why that's important. We think of energy efficiency in window installations and how do we deal with water that gets in around the rough opening. So that'll be a discussion. And then we'll also talk about venting. Like when we're venting a furnace or a hot water tank, what do we do to keep that moisture out of the attic? So those will be the main takeaways that we'll look for today. So let's start with talking about energy efficiency and specifically insulation. So here we have a wall cavity. We're going to insulate this with some form of insulation. Now, a lot of times a standard insulated wall will have R19 bats. And an R19 bat will give us an effective value of about R15.5. And the reason is we've got these studs here that are about R6.5, and they're about 23% of the wall assembly. So 23% is going to be R6.5. This part of the wall is going to be R19, so about 77% of the wall is R19. If we take the average, which is what we call the effective value, then we're at about R15.5. Now, how do I make this more energy efficient? Well, there's two ways to do it. One is I could put a thicker insulation bat in here or a denser insulation bat in here. So I could go an R22 bat or an R24 bat. But remember, I still have these studs here. So believe it or not, to go from an R19 bat to an R24 bat gives me a net wall assembly of about 1.5 R value better. So even though I'm adding R5, I'm only getting a 1.5 R value better. What's the cost of that? And what's the unintended consequences of that? So let's say I put an R24 bat here. How much have I reduced the amount of radiant heat loss through to the sheathing? And if the sheathing's colder and colder and colder, what's the risk of condensation and frost formation on this sheathing? So by adding the insulation between the studs, I'm really not doing myself much of a benefit, and the unintended consequences is a higher risk of condensation. However, if I was to simply put an inch or an inch and a half on the exterior, now I've insulated the studs too. So let's say I took and put R5 on the outside of this building. Well, an R5 here takes this stud from 6.5 to 11.5. It takes this R19 up to an additional R5, which is R24 here. So now if I take the overall average, I'm somewhere up around an average of an R21 effective overall. Plus, I've reduced the risk of condensation on this surface. So by adding the exterior insulation, there's a benefit there. But there is a caveat to this, because you have to add a minimum amount of insulation to the exterior to meet a ratio that the building code asks for. So it's called the inboard-outboard ratio. So if I simply put R3 outside of this, there's not enough insulation value to keep this warm enough. And the R3 outside is going to limit the ability of this wall assembly to dry outboard. And if it can't dry outboard, the R3 is actually going to give me more energy efficiency, but it's going to affect the ability to this wall or of this wall to be able to get rid of moisture. So I want to have a minimum amount on the outside. And for Alberta, that's typically about a 30 ratio. So a 1 in 30. So I want 30% of my insulation outboard of the sheathing. So I probably want about R5 outboard of my sheathing as a minimum. So when we're looking at exterior insulation on walls and we're looking at the tier codes and saying, how do I make my building more energy efficient? How do I improve my efficiency as I'm moving towards that 2030 net zero ready? Think about the consequences of putting the batts between with extra insulation and putting insulation on the exterior, and which one's going to perform better long term, which one's going to give you the most value, and which one's going to reduce the risks of the wall assembly. One of the other unintended consequences of adding exterior insulation here is how are you going to fasten your cladding, and particularly your trim. Your trim is going to have to go on around, so your cladding might be able to attach through the insulation to the studs, but what about trims around the window where you have this little space here where there's nothing to nail to? Now, the option here is to think about your exterior insulation as either going outboard of the sheathing, or you could put it between the sheathing and the studs, remembering that the building code does not account for that. So you may need to do some engineering moving forward, depending on the thickness of the insulation, depending on how you connect it within that wall. Because remember, you still need lateral support for that wall. So don't forget the engineering, meet the building code requirements for that lateral support, but also how are you going to connect the cladding on that surface? So let's talk about exterior insulation and talk about vapor permeability. So what is vapor permeability? Well, if I look at this exterior wall and I think, okay, I'm going to add an inch or an inch and a half of insulation outboard of the sheathing, the thing I have to think about is, can the wall dry? Can it get rid of the moisture that's accumulating within the wall? So we think of that vapor permeability. For instance, sometimes you'll see people putting a foil back insulation on the outside. Well, that's not a good idea because that prevents the vapor that's in the wall from escaping. It's kind of like when you think of a cotton shirt. If you wear a cotton shirt in the summertime, it can breathe. It can get rid of the vapor that builds up behind it. Whereas if you're wearing something that's more plastic, like a polyester shirt, that can trap that moisture in there. So it's the same principle with your house and with your wall. You need to be able to get rid of that moisture. Now, with that, you have the option at that point to be able to put the insulation either outboard of the sheathing, or you could even put it between the sheathing. Because here's another thing to think about. How are you connecting your cladding to the wall? And if you're putting cladding on the wall, you're at 16 inch on center or 24 inch on center, and maybe the cladding is allowed for that on center spacing. But what about the trim? You know, you have a space right here, and if you're putting trim right here around the window, do you have any way to connect it if you have that insulation on the exterior? So you want to think about, does the insulation go outboard? Does the sheathing go outboard? And then remember to tie in that lateral support or that structural component, because the building code doesn't really address how we add insulation to the exterior and how we make sure that it stays structural if we move the sheathing outboard of that insulation. So we want to keep those things in mind. How do we attach the cladding? How do we maintain a structural integrity? How do we make sure the wall can dry with the vapor permeance? So as we're moving towards higher levels of tier code, we can actually incorporate these things without having to rework it or halfway through construction, oh, we didn't think about that. We've thought about it and we can move forward, improving the performance, improving the energy efficiency, and having a building especially that will perform really well. So now let's turn our attention to windows and doors. We've been talking about insulation, and insulation is important when we look at the insulation around a rough opening, but there's a few other things that are more important than the insulation. First of all, let's think about the standard itself. It's called the CSA A440.4. Now there's a number of standards. There's the 440.1, 2, 3, 4, and 6. So we don't want to get confused by those. So just ignore that. But when we talk about the CSA standard itself, there's also years it's produced, similar to the building code. Now, with the current code, we've moved to the 2019 version of the CSA standard, the CSA A440.4 standard. And what that means is the old code, the 2019 code, would talk about the 2007 standard. And you remember that one, you had the nomograph, where we figured out what the exposure level was, and then we determined what sill protection to put in. Well, that's now completely changed. Now with the 2019 version, we're focusing on what it asks for window protection. So down here on the sill portion of the window, what is the requirement in 2019? Well, it's to protect the sills on every door and protect the sills on mold windows. Now, your question might be, well, what's a mold window? So a mold window is a window where we take a casement, for instance, and a picture, and we cut the flanges off two sides and we join them together. That's what we call a mold window. Now, a lot of windows will have a picture and a casement, but if they have an integral monolithic frame around them, then that's not a mold window. So that does not require to have a sill pan. So sill pans are only required on doors, all doors, and on windows that are mold. Now, part of this is how do we protect this rough opening if water gets in there? And right now the building code is pretty silent on how we do that. We do know that the building code talks about drainage. It talks about water that gets in needs to get out, but it's pretty silent on what we do in this rough opening. So what is the best practice when it comes to window installation that will meet the CSA A440.4 standard for 2019 and will also meet the Alberta Building Code for 2023? So one of the challenges is when we look at the building code, it asks for a first plane and a second plane of protection, but it doesn't define where that plane starts and stops. So for instance, if you read the building code in 9.27, it tells us that that weather barrier, that sheathing membrane we put on the outside, we have to seal the window or a duct or a pipe or any other penetration to that weather barrier. Well, with windows, we also need to provide drainage. That means the bottom of the outside flange on this window, we need that to be open enough so that water that gets into this rough opening right here can drain outside. So if water's getting in there, which it will, and a lot of times it will from upper sources. So if you look at this window here, you have an upper section, an upper floor, and you have a window above that. You have a soffit above that. You may have a deck above that. So those are the entry points. And if water gets in there, runs down the inside of the sheathing, it can drip into that window head right there. Now from there, the water runs down the sides and it reaches the bottom sill. So if we don't protect the bottom sill, yes, we can allow water to drain out, but what's the long-term problem with that? Well, the long-term problem is as we put more insulation and we improve the air tightness, we eliminate drying ability. And if we eliminate drying ability, then moisture that gets in there could get trapped and we start to see a deterioration of maybe the framing lumber, or we could see mold growth, biological growth. So we want to ensure that that bottom sill is protected. Now, it's not a mandatory requirement in the code other than doors and mold windows, but it is best practice and it is a way to reduce your overall service calls and callbacks. So you notice here that we've got shims that support the window and take the weight down. These shims shouldn't be moisture sensitive and we want to avoid nailing through them if possible. So we talked about the requirement to have this sill protection on mulled windows and doors. So why is that necessary? Well, if you think about a door, patio door, entry door, or a mulled window, they have a higher risk of leakage than do most windows nowadays. So we don't see a lot of mulled windows anymore, but we do see a lot of doors, patio doors, and entry doors, and the risk there is much higher. So we're looking for this sill protection. You notice here we have vinyl membrane because as part of the deck, we've installed the deck membrane and we've brought it up over the sill and onto the interior here. Now remember, we talked about having that sill protection needing to either have a back dam or a slope on it. What do the window manufacturers say? Well, it depends on the manufacturer because we have to be able to install these to meet the CSA A440.4 2019 standard, but we also have to meet the manufacturer's requirements. So when it comes to a door sill like this, if a window manufacturer has not accounted for shims and back dams, then we have to have an alternate method of dealing with the water that gets in there. With the sill pan here, the sill pan has been folded in underneath the door, and really the goal is either to have a slope sill or to have a back dam. Now, with the case of some of these windows, it's very difficult to get a shim and support for the sill at the bottom. So we want to follow the manufacturer's installation. And in that case, we could simply take this sill protection and fold it up and create our own back dam. And then when the flooring goes in, we have it shimmed up, the flooring comes up against it, and we've protected it so that water that gets under that door can't come into the building, but it's trapped into that little sill protection and it can drain back outside where it's safely dealt with. So as we talk about energy efficiency, the one thing that comes up is air tightness. And with air tightness in a party wall such as this, we always have penetrations and openings in the party wall. So as I'm talking about penetrations, I'm thinking about the plugs, the switches, the wires, anything else that's going to impact the air tightness of this wall. Now, one of the things with energy efficiency is when we're talking about energy efficiency, air tightness is a big part of that. So we know from, say, a single family house, if I improve my air tightness, I can improve my energy efficiency by up to 10 to 12%. Now, when I think about that from the standpoint of multifamily, because I don't have a lot of heat transfer between units, I'm not going to worry about the energy efficiency as much. So even though the code says that multifamily unit or this multifamily unit has to achieve a certain air change value, because the air is leaking between the two inner parts of the building, it doesn't have an impact on the energy efficiency. But even though it's not the energy efficiency, what it does impact is the amount of sound that travels, because sound is transferred through air, but it also affects the amount of odors that transfers through. So we do want to make sure that we get air tightness between units, not just for energy efficiency, but the benefit of making sure these party walls is nice and tight is that now we reduce the amount of transfer of odor and sound through. Now, how do we do that? Well, if you look at the boxes here, we have certain size boxes that's permitted. So we can't have a great big opening here. So we need to check the code. We can go a maximum of a couple of boxes, and that's in the building code. I don't have that off by memory, but you know, when you download your free copy, you'll be able to look that up. But when you think about this box, the other important aspect of it is how do I make it airtight? Now, the one you see here, I'm actually pretty impressed with how well that this putty pack is put on here, because they've taken the time, they've folded it to everything, they've made the joints nice and tight, and they've wrapped it tightly around the wire. So this is actually going to achieve really good air tightness ability. But there's other options. We could put a metal box in here, and we could put a drywall frame around it, we could put a drywall backer on it, and we can achieve air tightness that way. So there's a number of ways to do it, but there's two parts to this. There's the air tightness aspect, but then remember, this also has to meet a fire code requirement. So this box has to meet a certain fire rating. And once the putty pack goes on, that helps it to meet the rating. So don't just assume that any box off the shelf will work. Check and make sure it's the proper rated box make sure that the putty pack that goes with it is compatible, and make sure that that is going to be acceptable to your local AHJ, because different AHJs have different interpretations of what will work and what will not work. And you want to check with them to make sure that you're applying something that's going to work in both those applications. So really, we're looking for air tightness, we're looking for fire code, and we're making sure that this is going to perform, because the person living here and the person living here is going to benefit from us taking this seriously, the air tightness between the party walls. One of the things to consider with exhaust is when we have moisture coming out of an exhaust, we've all seen furnaces, hot water tanks where you get that big icicle buildup. Well, that moisture coming out of there can impact areas where it's close to a soffit line. So if you think of a soffit line that's just above a vent, for instance, up and behind me here we have a vent, and if you look closely you'll see that that vent is exhausting where there's non-vented soffit. And so in the building code in section 9.32, which is your section on ventilation, it tells you there if you're exhausting moisture in that exhaust, or if there's moisture in the exhaust you're venting. If you're exhausting air and it has moisture in it, for instance from a bathroom fan or from a furnace, then that exhaust has to be done in an area where it's either not close to the soffit or the soffit has been blocked off. So you can block that soffit off with something underneath the soffits, you can put non-vented soffitting, or you have to have that exhaust low enough. So when you look at the table in 9.32 in your free building code copy, you'll be able to look at the chart and say, when I put the exhaust out, number one, does it have moisture in it? And number two is, how close is it to the soffit? And then I can determine how to handle that. With the new building code, what we're seeing now is the introduction of ICF, or insulated concrete formwork. And what that is basically a Lego block of styrofoam, and you stack them up and fill them full of concrete. You can do forms where you have a form on one side and the other, and then connectors where you fill that full of concrete. But the difference now is, as an alternative to wood frame construction, you can use that as part of the compliance path for construction. And throughout the different areas in the building code, you'll be seeing, as an option, how to install that with, say, siding, how to install that when you're putting foundations in, how to install that when you're connecting to roofs and different things like that. So they've just integrated that in so that ICF is an acceptable solution within the building code itself. With regard to exterior claddings, there's been a couple of changes which can impact, especially if you're doing vinyl siding. Now, vinyl siding was never really detailed in the code, and now in 9.27 of the building code, it talks about the installation of vinyl siding, and particularly the nailing pattern that's required. So currently, the nailing pattern is described as being 400 on center. In other words, 16-inch on center. So if you're doing 24-inch on center stud spacing for vinyl siding, you won't be able to install that. You'll have to go back to 16-inch on center. Now, there's probably going to be some standards or revisions to that once testing comes out, but currently, you have to be 16-inch on center for vinyl siding. So that's one of the big changes. The other change is the fact that with the vinyl siding, and with other sidings as well, you have to hit the studs. So you need to install so that you get through the sheathing and the stud by at least 32 millimeters, and you have to get into the actual stud by at least 25 millimeters, so that's 1 inch. So those are things that you need to look at in the building code if you're installing vinyl siding to make sure that you're meeting the compliance requirements for that product. The installation of vertical siding, like you see behind me here. With vertical siding, we don't have to hit the studs for vertical siding to be attached correctly. We have to attach vertical siding at 300 millimeters on center, which is 12 inches on center. So we don't have to put studs at 12 inches on center. We just have to put a thicker sheathing on there. So the sheathing thickness needs to be 11 millimeters or 7/16 of an inch. And then in our vertical siding, we can install that 12 inches on center and we're good. Now, one of the other clarifications of confusion is earlier on in 9.27, it talks about a rain screen system or a drained and vented airspace. And it asks for a 9.5 millimeter or 3/8 of an inch spacing in there. That is for that drain screen or that space to dry that cavity out, or in the case of high water volume, to restrict the moisture of getting in there. But we don't want to confuse that with strapping that we put on to attach the vinyl siding. That strapping for the attachment needs to be 3/4 of an inch. So if we're thinking we can get a drained and vented rain screen system and use 3/8 of an inch and fasten our cladding to that, we could, as long as that strapping lines up with the studs. Because remember, with the vinyl siding, we have to get through and hit the stud for that installation. So those are a couple of things to keep in mind when we're installing exterior claddings, particularly vinyl siding. So one of the things that now we have to get used to is the fact that the windows can only be a certain distance off the finished floor for opening before we need protection. So we don't want a child to push the screen off and fall out the window. So we need to look at this and go, okay, so this window is at 900 millimeters is the height that we're looking for from finished floor. So this window is going to be pretty close. So we'd have to talk to the AHJ and make sure that they're telling us exactly where it needs to be. But for instance, let's say the window's down here at 28 inches. Then that's definitely going to fall under that new requirement. If the window is up here at 46 inches to the bottom of the window, then that doesn't really matter because it doesn't meet that new requirement. So if the window is 900 millimeters or less, we need to restrict the opening of that window less than 4 inches. So here's 4 inches. Let's just measure that. So 4 inches is right there. So we can't have that window open any more than that so that a child can't push the screen, fall out, and injure themselves. The other number to keep in mind, though, is we don't want to be any more than 1,800 millimeters from the ground below. So it determines the height at which the fall would occur. So what happens if this is an egress window and we have it locked at 4 inches opening, and yet we need to open it for egress this much? Well, there's a standata that Municipal Affairs has released to allow us to have best of both worlds. We can't have just the 4-inch opening and we can't have egress both. So we can put what's called a WOCD, or a window opening control device, so that we can set that so that a child can not get through here, and then a person could simply unlock that device to open it up for egress. And so we can meet both those codes. When we think about this, it really helps us to understand what we need to do. So talk to your local AHJ in terms of the exact distance that they want this done. Is it here to 900 millimeters? Is it this ledge to 900 millimeters? Because that's the defining point that we need to understand from wherever you're building what they want that interpretation to be. One of the other new changes is with rated walls. When we have a 45-minute rated wall, we need to make sure that the horizontal joints within here for the drywall are blocked in such a way that we can put additional fasteners in. Now the reason for this is, if you think of this wall as being rated, when there's a fire within here and we don't want it to move to the building next door, this gets really, really hot. And the temperature within here gets well above 1,000 degrees. So if the heat moves through that opening where that block is, it can actually cause this wood in this wall to combust. And so to try and reduce the air getting in there to cause the combustion, if there is a fire, then we would put blocking here. And then when we put the drywall on, we just can put additional fasteners in that blocking. So that's the purpose of putting the blocking. But you want to remember that in a rated wall, you need that blocking wherever you're going to put that. So if this is a 9-foot wall and you have one joint, one row of blocks. If you end up with a 9-foot wall with 2 joints, you need 2 rows of blocks. So just keep that in mind when it comes to rated walls. So now that we've gone through a lot of the new changes in the building code, we can do a quick review, and some of the things that you want to take away, we can pinpoint those. So we talked about insulation. Should we put it between the studs? Should we put it outside on the wall? We talked about air tightness of the party wall. And with that air tightness, how do we deal with penetrations in the party wall? Because that's a combination of air tightness, but it's also fire code because we have to protect that box that we put in the wall and make sure our opening isn't too large. We talked about the CSA and the window installation and where we need sill pan protection and where we don't, and how to address things like fall protection for children in the window, and how do we deal with the egress versus the opening for the fall protection. So we've talked about that. We also went into the cladding attachments and talked about the fact that right now in the building code, the vinyl siding needs to be installed 16-inch on center, but for vertical siding, we need that installed at 12 inches on center, but not to the stud, but to at least a 7/16 sheathing material. So those are some of the key takeaways that we can remember from this discussion. Thanks for joining us for the building envelope improvement video. And keep an eye out for upcoming videos which will help you with the new building code. And don't forget to download your free copy of the new Alberta Building Code.